Okay. So yeah, I mean, best thing you could do here for these types of problems is do negative b over 2a to find x according to the vertex. So like, for example, if you look at number 3, you do negative of negative 6 or 2 times 1, which of course is 3. And you plug 3 in, which is 9, minus 18 plus 9, which is 0. So 3 comma 0 is your vertex, and it opens up. So you look at 3 comma 0, which is going to be right here, and it opens up. That's the only one that does that. So that's how you can go about those problems, just so you know. I'm not going to go through all 9 because that just takes too long. For 10, if you're asked to find the equation of parabola, you're given a minimum or a maximum. That's a vertex, right? So probably vertex form is your best bet to start with and go in that direction. And if you're given another point, plug in for x and y and solve for a, because that's the leading coefficient. There you go. We got it, right? So that's just all algebra. Hopefully you guys are cool with that. 11 through 14 are very similar to the notes, right? You're just trying to like dissect each equation, like what's the x-intercept, what's the y-intercept, what's the vertex? Is the vertex a high or low? If it's opening up, the vertex is a low. If it's opening down, the vertex is a high. So it's always going to be all real numbers in interval notation, whereas negative infinity with parentheses. The range won't be all real, but it'll be going either towards infinity or negative infinity, depending how it opens. And you know, the vertex, the y-coordinate of the vertex helps determine the range. So that should all be pretty straightforward, I feel. If it's in vertex form, then there you go. You should still find the first. Probably the x-intercept might be the hardest part for any of these problems, I suppose, because it requires a little bit of extra work, like factoring or Claude form. 13 was a pretty easy x-intercept because there was no k value, but 14 required a little more work to find that x-intercept. More matching, but these are in vertex form as opposed to standard form for the first page, 1 through 9. And again, just to identify the vertex was opening up or down. That should be pretty easy for matching. The word problems. Questions on the word problems at all? We're good? We're okay? Make up variables. So sum of two numbers, call them x and y. X plus y is 31. X minus y is 41. Solve the system of equations. That's pretty easy. Actually, I'm not sure how that fits with quadratic equations, to be honest with you. But 25 does, because you have x times y. When you substitute, you're going to have something quadratic in nature, and you solve that, and you get your answers as a result. 26 is dealing with physics, right? So projectile motion. If you're given the equation, so just have to work with that equation. If you want to see where it is 3 seconds after you threw it, great, plug in 3. How long does it take to hit the ground? Plug in 0 for y, and solve for x. So you find the x-intercept. It's been a long week. And remember, no negative values, right? Because you can't go back in time. 27, draw. You have length and width, and you have the length in terms of the width, so you can substitute that way. Yeah, there we go. And solve it. And again, anything that's like negative, you would ignore. It doesn't really mean much to us. And then same thing with projectile motion. This is an intercept form. And so you can find the vertex that way. Let me zoom in. That's really small. Okay. Maybe you can still read. But it's right up in schools, just so you know. But yeah, I don't know why Mrs. Sasui felt like blowing that. You know where your x-intercepts are. The vertex is going to be right in between. At the initial height. Okay, so we had to do that. Never mind. We had to actually expand it. Or I guess you could plug in 0 for t. I don't know. Could have done that too. And yeah, when it hits the ground, that's the x-intercept. Height, maximum height, that's the vertex. And d is also part of the vertex. But that's the actual maximum height. Okay, so that should cover quadratic functions. We're not going to really simmer on too much because we got to move on to other stuff. So, well, this is a review of algebra 2, right? Think of it this way. Now we move on to polynomial functions because remember, quadratic functions is one entire unit in algebra 2. Polynomials, we also know the unit, but we're going to do that one day. So if you guys get your notes out, let's get started. Yeah, we'll just talk about, you need notes, yes. Excuse me, not. All right. So polynomial functions. Basically, it's just a function of a lot of terms, hence the word poly. But very important, every term has to follow this kind of nature. X to some power, where that is a whole number. Like you can't have x and -3 power. That's not going to be a polynomial function. You can't have like x to the 1/2 power. That's not a polynomial function. Guaranteed you need to have the exponent be a whole number. The highest power, the coefficient next to the highest power is called leading coefficient. The highest power itself is called the degree of the function. These are nice and smooth continuous curves, no breaks or sharp corners. So which ones follow a polynomial function? Definitely that one and that one. That's no, because you have a sharp corner. That's no, because you have a break. Right? And let me get rid of the other check marks. It's a little distracting. But yeah, the first and third ones for sure. Not the second and fourth ones for those reasons. Questions on that? Make sense? Good? Cool. The leading coefficient test, this is more telling you the end behavior than anything else. Not sure why it's called leading coefficient. I mean, you do look at the leading coefficient, obviously. But this is all about end behavior. So you see how like it's down up or up down or up up down down. If it's even, the arrows go in the same direction. If it's odd, the arrows go in the opposite direction. That helps. The arrows kind of like at odds with each other. The arrows kind of go see eye to eye when they're even, when there's an even degree. And remember, the degree is the highest exponent in the polynomial function. Overall, the graph will be rising off to the right if your leading coefficient is positive. Yeah, overall, it's going to be going down to the right. If overall your leading coefficient is negative, because when x gets bigger, y gets smaller. If your leading coefficient is negative. For even, it's pretty easy. If you have an even degree, but a positive leading coefficient, both arrows up. It's like smiley face, right? Or down if the leading coefficient is negative. So that's just the summary of it. And from a limit perspective, we write like this. Positive or negative infinity. But all depends on the degree and leading coefficients. All depends on those two things. So for example, clearly this is up. Clearly this is down over here. So you're going to say the following. X approaches negative infinity. X approaches positive infinity. And here, same thing. And here, same thing. Then we're going to say this. Shoot, maybe I must have no space here. Let me get rid of that line. It's kind of annoying. Excuse me. Okay, let's look at example 2. If you're going to the left, is the arrow pointing up or down? Up. So you can say positive infinity. Now for example 2 again, as we look at the right arrow. So this is the left arrow. How about the right arrow? Is the arrow pointing up or down? So you put negative infinity. You always write the x part, x going to negative infinity, x going to positive infinity, because you always want to know what's going on to the left and to the right. Oh, shoot. Okay. For this one, kind of hard to tell. But what do you think y is approaching as we go further to the left? What do you think it's diving towards? Probably a little higher. Because look at the right side, it's breaking the x-axis. Is there a horizontal asymptote, you guys think? Yeah, it's 1. So we're gonna say it's 1. That's a horizontal asymptote. That's an end behavior, just so you know. Horizontal asymptotes are end behavior. And then for this one, we kind of know what's going to happen. It's going to look kind of like this. Down, down. What will I say about the end behavior about this?
Negative.
Yep, perfect, got it. Yep, that's it. Okay, zero's a polynomial. Those are just x-intercepts. So in this case, you can do a lot of factoring if you can. How would I factor that? What would you guys say? You can, but I would actually approach it a little differently. Because we're going to want complex numbers, that's why. Well, think about it. Is 256 a perfect square? Can two numbers multiply 256? Two integers. You could use a calculator if you need to. I mean, in that case, what's square root of 256? You want to take a stab? What it could be? Pretty close. I'll take the over. 16, yeah. Okay, I'll take. I know the answer, so I'll take the over. All right, I win. All right, so yeah, 16. Oh, sorry, it's x squared. My bad. Can we break this down even further? Yeah. So you can see why that's probably why I wouldn't have moved that 256 over. I mean, the intent is good, but I wouldn't have done that because you wouldn't get quite the whole picture. And I'm going to replace f of x with 0 because that's my goal now, is to set y equal to 0, because zeros are when y equals 0, right? And remember, y equals f of x. So I should be able to get the answers now. Like, where are my answers now? Well, you have one factor.
Plus or minus 4.
Yeah, definitely 4. Definitely negative 4. Yeah, plus minus 4i. Good, you got it. Hence why we talk about complex numbers to begin this unit. Yep, plus minus 4i. Okay, cool. We're good? Okay. You could use Desmos, I guess, if you wanted to. But here's the thing: the number of turning points will have at most n minus 1, and where n's a degree. So my degree here is 3. So it can have 2 turning points. I'll probably do some factoring here. What can you factor out of this guy, this equation? X for sure, right? And let's put in order: x squared minus 2x plus 1. Okay. The zeros are 0 and 1. Hold on. Does it have 2 turning points? I think it does. Let's go to Desmos. I'm going to cheat. So y equals x. Yeah, there's 2 turning points. Turning points are basically highs and lows. So like it's a high, then a low, then back up again. So yeah, there we go. Okay, I feel good about that one. So let's close that one down, close that one down. Cool. Multiplicity. Multiplicity is the number of times the 0 occurs. So the problem we just did, we saw x minus 1 squared. So the 1 had a multiplicity of 2. So k represents the multiplicity. So the number of times a factor appears is the multiplicity of that x-intercept. So if you look at this example, it's already factored for you. Was there a question? No, you're good. All right. We see that 0 is an x-intercept as well as 4 and -1. But the 4 happens twice. The -1 happens 3 times. Yeah, it's kind of hard to tell, but there are 2 x-intercepts there. Just really close together. So you always cross at odd multiplicities. Very important. Odd multiplicities always cross. Even multiplicities always bounce. The real reason why that happens, which I don't know if it's discussed here, but should be discussed. Yeah, it's kind of unfortunate. That's a missed opportunity. Let me discuss this with you guys. The real reason why that happens. Oh, cool. Ready? There's something called a sign chart. So here's -1, here's 0, here's 4. So we definitely have a bounce at 4. And we have a cross. So if you were to do a what we call a sign chart. And here's your equation, right? Let's start on the far right. If you plug 5 into this equation, is y positive or negative? So you do 5 times 5 minus 4 squared times 5 plus 1 cubed. So look at x. Would x be positive or negative when you plug 5 in? Positive, right? How about if you plug 5 into x minus 4? Positive or negative? How about x plus 1? Yeah. So what this means is that the graph will be above the x-axis. Because these are the y values. These are y values. Are the y values positive or negative? If you're positive y value, you're above the x-axis, right? Now here's the deal. What if I plug in a number between 0 and 4? Say like 3, for example. And how am I creating the sign chart? Based upon the x-intercepts. The x-intercepts help define the sign chart. So it's like a number line analysis. Don't know if this was covered in Algebra 2 with you guys. I know I covered my Algebra 2 class, but I don't know if, but there's 3 different teachers, so I don't know. But if I plug 3 in, okay, that's positive. 3 minus 4, that's negative, but you're squaring. See, the squaring brings it back to being positive. And 3 plus 1 cubed, positive again. So it's still positive. That's why we see a bounce when you have an even exponent next to the factor that got that 0. 4, why do we have 4 in the first place? That came from x minus 4 squared. That's squared. That's going to be a bounce. We're above the x-axis there. Then you're going to see an alternation. You always see an alternation whenever the exponent is negative next to that 0. So like x by itself, just x to the 1 power. X plus 1 is x plus 1 cubed, also an odd exponent. You're going to see a sign change. You can plug in numbers if you want, like -1/2, for example, or -2. Trust me, you'll see those sign changes there. So that's the main reason why we see those bounces, just so you know. So not just to memorize, but to understand why it happens. Might take more time for me to explain it again and keep reinforcing it, but that's what's happening. All right. Good, we're at the home stretch here. Perfect timing. Good. You guys can get to our homework too. Find the real zeros of the polynomial and determine their multiplicity. Okay. It's factored for you. That's nice. I don't want you guys to factor it, but it's all good. What's your highest exponent here? 4, right? Oh, what you have to do is no worries. You have to look at the standard form. My bad. You have to look at the standard form. No, I I confused you guys. So I gave you two forms of it. Now, what are your x-intercepts though? That's where I look at this. Totally. And also 0. The -4 happens once. The 0 happens once. The 2 happens twice. The maximum or extrema, which is basically turning points. Yeah, extrema is the plural of extremes. We don't say extremes. That's poor grammar. Yeah, so we say extrema for plural. So that means turning points. There's 3. Remember, it's n-1, right? It's only 3. All right, let's keep moving. Actually, I probably should zoom out, I think. Hold on.
What is subtracting 1 from?
From n. Yeah. Hold on, let me write this again. It's 4, 0, -4, 2, 3. And that's once. Okay, so graph will look like this. Actually, let's see what I'm doing here. Let's just do this. So your end behavior is going to look like this. And the y-intercept is 0. And we bounce at 2. Here we go. There's the graph. Okay, we're good? Okay. I think we're all set. Homework is going to be this right here. Pretty short, actually. You guys could totally knock this out. Have no homework over the weekend. So go for it. Answer keys in Schoology. Ask questions, and we're done.